Okay, Thursday, October 2020, which is also May 2020, pure free by the one and only Miss Hayden Higgins. Okay, here we go. Are we ready? So, question 1. Solve for 0 is less than or equal to x is less than 360 degrees, the equation 2 cos 2x equals 7 cos x, given your solutions to one decimal place. Okay, the first thing you should be thinking is double angle formula. Okay, you've got cos of 2x. Now, I don't know the double angle formula off by heart. Okay, you know why? Because I don't need to. Okay, but that's okay. No, all jokes aside, if you don't know the double angle formula off by heart, in the formula book, you've got cos of A plus B. So essentially, you could do cos of A plus A. So, cos of A plus A is the same as cos of 2A, or 2x essentially. This is going to give you cos squared A plus, minus sine squared A. That's what that's going to give you, okay, if I use the substitution from the formula book. Now, I also know that cos squared x plus sine squared x equals 1. Okay, so sine squared x is in fact 1 minus cos squared x, isn't it? So sine squared x equals 1 minus cos squared x. So therefore, cos of 2x actually equals cos squared x plus, minus 1 minus cos squared x. So we're actually going to end up with 2 cos squared x minus 1. Okay? Now, a lot of you should remember cos of 2x equals 2 cos squared x minus 1. But if you don't, it doesn't matter, because you can use the formula book to help you to do this, okay? So here we go. Now, the reason I've done this is we want to solve this equation. Really, when we're looking to solve an equation, we solve it, it's easy if we have a quadratic, is it not? So this is why I'm going to use this variation, so that I can substitute into here. So here we go. I'm going to get 2 lots of cos of 2x, which we know is this, bracket, 2 cos squared x minus 1. Some of you may have started straight at this step if you've memorised it, okay? And this equals 7 cos of x. Multiply it out, I'm going to get 4 cos squared x minus 2 minus 7 cos x equals 0. So I'm going to have 4 cos squared x minus 7 cos of x minus 2 equals 0. What do I have here? A quadratic equation. Okay, so I can use my calculator to solve this, and when I solve this equal to 0, I'm going to get cos, using my calculator, cos of x equals 2, and cos of x equals negative a quarter. Now, we know straight away that we're going to reject cos of x equals 2 because that's impossible, okay? So I always like to write reject. Okay, so we have cos of x equals a quarter. Now, if cos of x equals a quarter, we only want it between 0 and 360, which is quite nice. So to find x, we're going to do cos of minus 1 to minus a quarter. Now, obviously, I forgot to say one thing. The question's in degrees. What should your calculator be in? Degrees, absolutely. So make sure you put it into degrees. So if I do shift cos of minus a quarter, okay, I get 104.77 degrees. Okay, so I'm going to use my lovely diagram. Okay, CAST. I know this is 0, 180, and I've got x equals 104.4775, so it's around roughly here. Okay, this is my angle. Now this is negative a quarter, okay? You have to think we do the opposite. Normally we would have, you know, between 0, 19, we'd reflect it in the vertical line, okay? We still reflect in the vertical line. If we reflect this in the vertical line, we get here, okay? And this angle doesn't change. This is still 104.477. So to find, if we start at 0 and we go all the way around to this angle, I need to do 360 minus 100. Okay, so in my calculator, I'm going to do 360 minus answer. So then I also get x equals 255.522, blah, blah, blah. Okay, I'm going to stop right there. I'm going to go back to the question. It clearly says, given your solutions to 1 decimal place. So therefore, x equals 104.5 degrees and 255.5 degrees. There we have a nice, easy 5 marks. And you could do this question without having to memorise the double angle formula. Question 2. A scientist monitored the growth of bacteria on a dish over a 30-day period. The area n millimetres squared of the dish covered by bacteria t days after monitoring began is modelled by the equation log base 10 n equals 0.0646t plus 1.47a. Show that this equation may be written in the form n equals ab to the power of t. Okay, so if I want to write it in this form, how do I get rid of the log? Okay, what do I need to do to get it into this form? Or how could I get it into this form? Okay, I know that log 10n equals something. I know that log to the base a of b equals c means a to the power of c equals b. Does it not? Yep. So this means that 10 to the power of 0.0646t plus 1.478 equals n. Okay? Another law that I know that a to the power of b times a to the power of c equals a to the power of b plus c. So I'm going to get 10 to the power of 0.0646t times 10 to the power of 1.478 equals n. Because I've gone backwards essentially, haven't I? Now, 10 to the power of 0.646t, again, the other law that I know. A to the power of b, all to the power of c, is the same as a to the power of b times c. So I'm going to go backwards. So now, I know 10 to the power of 0.0646 to the power, 10 to the power of 0.0646 all to the power of t is the same thing, times 10 to the power of 1.478 equals n. So now what I'm going to do is I'm going to put this into my calculator, okay? And it does say, show that it may be written in this case where a and b are constants to be found, give the value of a to the nearest integer and the value of b to 3 significant figures. So when I put a into my calculator, 10 to the power of 1.478, I get 30.06. To the nearest integer is clearly 30. Okay? Then when I put 10 to the power of 0.0646, I get 1.603, 3 significant figures, 1.16 to the power of t. So now I'm going to rewrite that. So therefore, n equals 30 times 1.16 to the power of t. Okay? Make sure you've rounded it correctly. Okay, so that was worth 4 marks, and these two were from, you know, these are from GCSE, these two, but the log law is obviously from Pure 2. Again, nice and easy question, I felt. Just slightly different, challenges you. Okay, part B, use the model to find the area of the dish covered by bacteria 30 days after monitoring began. Give your answer in millimetres squared to 2 significant figures. Well, this is easy. We just literally need to substitute T equals 30. So I'm going to write what we're going to substitute. I'm going to have N equals 30 times 1.16 to the power of 30. So in my calculator, 30 times 1.16 to the power of 30, I get N equals 2575.49 ... It clearly says 2 significant figures, 1, 2. So it means I'm rounding to the nearest 100. So N equals 2,600 millimetres squared. Okay, please make sure you're rounded. Again, I think that's quite a nice 6 marks. Okay, question 3. Figure 1 shows a sketch of the curve of the equation y equals fx, where fx equals 2x plus 3 over the square root of 4x minus 1, where x is greater than a quarter. So, find in the simplest form the differential of f of x. Okay, nice and easy. What do we have? A fraction. The first thing we should be thinking is v on the denominator, u on the numerator. So, when we are, this is quotient rule, differentiation, v du minus u dv all over v squared. Okay, and to make the life really easy for everyone, we're going to write everything down. So u, 2x plus 3, du is the differential of 2x plus 3, which we should all be happy with, 2. Okay, v is 4x minus 1 to the power of a half. dv. Okay, now, remember, this is chain rule. So first we differentiate the brackets. This is a half. Bring the power down, 4x minus 1 to the power of negative a half. Then we need to multiply by the differential of the bracket. The differential of the bracket is 4x minus 1. If we differentiate that, we get 4. So for dv, a half times 4 is 2. So we're going to get 2 bracket 4x minus 1 to the power of negative a half. Okay? Then, ultimately, we have v squared. Now, we have 4x to the minus 1 to the power of a half, all squared. That actually just gives me 4x minus 1. Okay, so I've got everything I need. I'm going to go up here now. So, let's start with what we know. So, v du, so these two together. Okay, so I'm going to get 2x plus 3 times 2 lots of 4x minus 1 to the minus a half. Yeah? Then minus u dv. Oh, that's quite a nice one, actually. I mean, v du. No, u dv. I've done it the wrong way round. Okay. Don't worry. Let's see if this works. Oh. Okay, I don't know what I did there. Okay, anyway, I can't believe I made that mistake. Right. So, sorry everyone. It's v du minus u dv. So this is 2 lots of 4x minus 1 to the power of a half. Okay. All of this is over v squared, which we know is 4x minus 1. Okay. Great. Most people got to this stage. And that's amazing. But this isn't fully simplified form, obviously. And when we think simplifying fractions, really what I think about is factorising and cancelling. Okay? So, here we go. I'm going to do not what the mark scheme says, because it's not what I would normally do. What I would normally do is this. Okay, I have 2 lots of 4x minus 1 to the power of a half. Okay? Minus 2 lots of 2x plus 3 over 4x minus 1 to the power of a half, because we know that's a negative, right? Then all of this is over 4x minus 1. Okay, now from here, I would probably multiply everything by this denominator to get rid of it. Just like we do, you know, sometimes we do the trig questions. So if I multiply everything by 4x minus 1 to the power of a half, okay, over, this is the same as multiplying by 1. If you multiply every term by it, isn't it? So now, I'm going to have 2 lots of 4x minus 1 to the power of a half multiplied by 4x minus 1 to the power of a half, minus 2 lots of 2x plus 3, 4x to the minus 1 to the power of a half, over 4x minus 1 to the power of a half, all of that over 4x minus 1 to the power of a half times 4x minus 1. Okay, so now if I simplify this, I'm going to get 4 to the power of half times half is just a whole one, isn't it? So I'm going to get 2 lots of that bracket. So 2 bracket 4x minus 1. I know on this one, these are going to cancel, aren't they? Because we've got a half and a half. So that's the whole point why we did this. We're going to have minus 2 lots of 2x plus 3. Okay, that looks a bit better because we can actually expand and simplify that now, can't we? Because the brackets are to the power of 1. All over, and then for the denominator, we've got a half times to the power of 1. They're the same, so it's just to the power of 3 over 2. So I'm going to have 4x minus 1 to the power of 3 over 2. If I expand my numerator, I'm going to get 8x minus 2 minus 4x minus 6 over 4x minus 1 to the power of 3 over 2, which is going to equal 8x minus 4x, it's 4x minus 2 minus 6 minus 8, all over 4x minus 1 to the power of 3 over 2. Okay, so to be honest, I really think that was quite a difficult question for 4 marks because I think it was quite unfair if you got to this stage that it was only 2 marks. Okay? You got another mark for trying to multiply by 4x minus 1 to the half, but I wouldn't have spotted that straight away without having to rearrange like this. Okay? Part B. Okay, hence find the range of f. So the range of f means my y coordinates. Now we know it says, it shows a sketch where f of x equals this. Okay, we know that the range of f is going to be from our minimum point on the graph upwards, isn't it? Okay, how do we find the minimum? It's when the gradient equals 0. It's when a stationary point. So we put our gradient. When does our gradient equal 0? Okay? When does our gradient equal 0? This is when 4x minus 8 equals 0. So when 4x equals 8, so x equals 2. Our gradient equals 0 when x equals 2. When I substitute x equals 2 back into f of x, we're going to get 2 lots of 2 plus 3 over the square root of 4 lots of 2 minus 1 to, oh, wait there everyone. What's 4 plus 3 is 7. 8 minus 1 over root 7. Okay, we need to rationalise the denominator here. If we multiply the numerator and denominator by root 7, oh, we actually just get root 7. Okay, so we know our function is always going to be greater than, it means this point here must be root 7. So, f of x, our range of values for f of x is always going to be greater than or equal to the square root of 7. Okay, that is a nice and easy 3 marks. Providing, obviously, you'll still be able to figure it out even if you didn't simplify up here, because you could still substitute in 0 here. It might just be a bit more of a pain, and that's why they ask you to simplify it. Okay, question 4, functions. Okay, so this one was quite easy. Part A, find f of 6. So for part A, we're going to find f of 6. So step 1, we're going to put in f of 6. When I put in f of 6, I'm going to get 21 minus 2 lots of 2 minus 6. Okay, remember we're going to take the modulus, aren't we? So this is going to actually be 21 minus 2 lots of, I know that's minus 4, but we're going to say it's 4. So it's 21 minus 8, which is in fact 13. Okay, so now what we're going to do is we're going to find f of 6. f of 6 is 13, so now we need to find f of 13, which is 21 minus 2 lots of 2 minus 13. Okay, 2 lots of minus 13 is minus 11. Sorry, 2 minus 13 is minus 11, but we take the positive, don't we? So we're going to get minus 2 times positive 11, which is minus 22. 21 minus 22 is minus 1. So f of 13 is minus 1. Okay? Nice and simple. Okay, part B. Solve the equation f of x equals 5x. Okay, we're going to solve the equation. Now remember, when we're solving a modulus, there's 2 ways to do this. To get a modulus into a bracket, we do one of 2 things. So we're going to have 21 minus 2 lots of 2 minus x equals 5x. And we're going to have 21 minus 2 lots of, and then we multiply everything inside the bracket by minus 1. Minus 2 plus x equals 5x. So you can see the difference is where the modulus would be. One, we've taken the positive, one, we multiply everything by negative 1. So we're going to have 21 minus 4 plus 2x equals 5x. 21 minus 4 is 17 equals 3x. 17 over 3 equals x. Have I gone wrong? No idea. Pardon? Okay. Then for the other side, I'm going to get 21 plus 4 minus 2x equals 5x. Get 25 equals 7x. X equals 25 over. But if we think about it, okay, the question is y equals 5x. We know 5x is a straight line, okay, that crosses through the origin. So it's got a gradient of 5. So it's going to be quite steep. Now, we can see in this area where it's going to be steep, it could either cross here or it could cross here. So only one of these are going to be a solution, okay? We need to find the one which has got a gradient less than 5, okay, or else it would be too much. 17 over 3 is 5.66. 25 over 7 is 3 point something. So we're going to reject this because this point is over here somewhere, and 25 over 7 is actually going to cross through our straight line. So this is why it is only, and you need to write that, x equals 25 over 7, okay? When in doubt, draw it out and ask Mr. Jacob. Okay, part C. So, given that the equation f of x equals k, where k is a constant and has exactly 2 roots. Okay, so I'm just going to take away this drawing. Okay, f of x equals k. That means we have an equation y equals k. Okay? And it has exactly, it intersects twice, doesn't it? Is that what it said? Yeah, it has exactly 2 roots when it equals a number. So that means if my k has to be between this point, because if my straight line here goes across here, I'm going to have 2, aren't I? And so it can be less than or equal to this point here, can't it? Part C. We know it could be less than or equal to this low point. Or it's only going to be less than the turning point at the top, isn't it? Yeah? Because if I go to the top, it's going to touch it once. My line K has to be in between these 2 lines. So let's delete this picture so that we can see what's going on. Okay, so then we know that this line is when x equals 0. Why? Because this is where we cross the axes. So when x equals 0, I have y equals 21 minus 2 lots of 2. So y equals 17. Okay, so I know that 17 is this coordinate here. Okay, so now we need to find this one here. Okay, and that is when the modulus equals 0. Okay, so when the modulus equals 0, x equals 2. So to find out what y is, we substitute back in, and we're going to get 21, aren't we? So then y equals 21, so we're going to have 21 here. This is 221. Okay, so that's part C done. Okay, part B, D. The graph of the equation y equals f of x is transformed onto the graph of the equation y equals AF of x minus b. The vertex of the graph of the equation y equals AF x minus b is 6, 3. Given that a and b are constants, find the value of a and the value of b. Okay, so we've had a transformation on the graph. The vertex is 6, 3, and it was 221. So 221, and we've gone to 6, 3. Now, first of all, AF x minus b. Okay, is A inside or outside the bracket? Outside. Who does it affect? Y, and what do we do to our y coordinates? We multiply by A. So y multiplied by A. Okay? Is B inside or outside the bracket? Inside. What do we do to our x coordinates? We add B. Okay? So if you think about it, y times A, so 21 times the number is 3. So my A must be 1/7. And then 2 plus B is 6. So that means my B is 4. So literally it's about breaking it down and going back to, you know, what do we do? How do we do it? Again, this is GCSE, isn't it? Inside or outside the bracket? Who does it affect? Why? And then you can, you know, do all of that. So well done. Question 5. Show that sine of 3x is completely equivalent to 3 sine x minus 4 sine cubed x. Okay. What am I thinking? Double angle formula. That's what I'm thinking. So I know for part A, I'm going to use sine of 2x plus x, which equals, and from the formula book, I'm going to get sine of 2x cos x plus cos of 2x sine x. Okay. And again, I can't believe they're making us do it. We've got another double angle formula. We're going to do it twice, maybe 3 times. Got one for this one for this one. Now, I showed you earlier you can work this out. I'm not working this out. Sine of 2x can be substituted as sine x cos x, 2 lots of that. And then obviously we have our cos x. Plus, do you know what, actually, everyone? I'm just going to, 1 second. I'm just going to move this here, but you all know it's the same, just so I've got my room. Okay, plus, and then we have, what is cos 2 of x? Now, let's think about this. Let's be intelligent, okay? We only want sines on this side. So I'm going to substitute it with the double angle formula just with the sines. We actually worked it out in question 1. And it was 1 minus sine squared x multiplied by sine x. So now what I'm going to do, expand, simplify, etc. So I'm going to get 2 sine x cos x times cos x is actually 2 sine x cos squared x. Now I know something about cos squared. I know that if we add sine squared to it, we get 1. So cos squared can actually be rearranged, and I could rewrite that as 2 sine x, and instead of writing cos squared, I know this is 1 minus sine squared x. Okay? Then I've got plus, and I'm going to multiply this out. 1 times sine x is sine x, minus sine squared x times, I'm going to get minus sine cubed x. Okay? 2 sine x times 1 is 2 sine x. 2 sine x times minus sine squared x is minus 2 sine squared x. Then we're going to have plus sine x minus sine, oh sorry, that's a cubed x. Okay, already I can see I've gone wrong somewhere. Okay, because I should be getting 4 sine cubed x. Is this supposed to be a 2 here? Yes, it is. So this is a 2. So this is a 2. Perfect. So then I'm going to get plus sine x minus 2 sine 3x. This is going to simplify to 2 sine x plus sine x is 3 sine x minus 4 sine cubed x, which is exactly what it wanted. This is what sine of 3x equals. Therefore, proved. Okay. Now, I know you might think sometimes that, you know, the exam boards are a bit harsh, they throw in some awful questions, but guess what? If they give you a part A, it normally links to part B, okay? So, they've then told you to integrate sine cubed x. They've given you a formula at the top with sine cubed in it. Let's rearrange that formula, ready to integrate. So for part B, I want to integrate sine cubed x, but what I'm going to do is in the beginning, I don't know how to integrate sine cubed x. So I'm going to rearrange this lovely formula that we've just proved, okay? When in doubt, look up. Okay, look up to the previous part of the question. Right, so here we have sine of 3x minus 3 sine x equals minus 4 sine cubed x, okay? Now I'm going to divide everything by minus 4, and I'm going to just write it a bit nicer. So 3, is everyone happy? Minus 3 sine x divided by minus 4 is going to be a positive, so I'm just going to put that at the front. 3 over 4 sine x minus a quarter sine of 3x, okay? This is what that equals. So now, I'm going to start part B again. I'm going to have the integral between pi over 3 and 0. And instead of sine cubed x, I'm going to have 3/4 sine x minus a quarter sine of 3x with respect to x. Because we don't know how to integrate sine cubed x yet. Okay? Now, when I'm integrating or differentiating with trig, I'm always going to write sine cos minus cos. It's just there. It's just going to help me. Okay, so I can integrate this. I know I can. Okay? If I integrate sine, I get minus cos. So this is going to be minus 3/4 cos of x. And I don't need to apply chain rule or anything like that because you know, it's just sine of x on its own. Now, for the second part, this one, minus a quarter sine of 3x. So minus sine of 3x integrated is a positive cos. Okay? So we know this is going to be plus cos of 3x. But remember, we also have to, I've got a quarter, and then this is chain rule again. I divide by the differential of the bracket. My bracket is 3x. So I'm going to do a quarter divided by 3, which is actually 1 over 12. So I don't need to write plus c, because I'm going to find exact values. I'm going to put in pi over 3 and 0. Okay? So what's going to happen is I'm going to substitute in minus 3 over 4 cos pi over 3 plus 1 over 12 cos pi over 3 times 3 is just pi. okay? Minus, remember this is when I substitute in pi over 3, I'm going to substitute in 0. You're going to get minus 3 over 4 cos 0 plus 1 over 12 cos of 0. Okay, well it's 0 times 3, which we know is 0. Now magically, when I put this into my calculator and press equals, I get 5 over 24. Nice and easy.
Question 6. Figure 3 shows a sketch of curve C1 with equation y equals 5e to the power of x minus 1 plus 3, and curve C2 with the equation y equals 10 minus x squared. The point P lies on C1 and has y coordinate 18. Find the x coordinate of P, write in your answer in the form ln k, where k is a constant to be found. So we know that the equation C1 has a y coordinate of P, so this is equal to 18. So for part A, we have 18 equals 5e to the power of x minus 1 plus 3. If I rearrange this, if I take away 3 from both sides, I get 15 equals 5e to the x minus 1. Divide both sides by 5. 3 equals e to the power of x minus 1. And then what I'm going to do is I'm going to ln both sides. So I'm going to get ln of 3 equals x minus 1. Therefore, x equals ln of 3 plus 1. But it wants it in the form ln k. We know that 1, if we want to write this in terms of ln, can be written as ln e. So we're going to have ln 3 plus ln e. Now we know that when we add lns, we can actually multiply the inside, which is going to equal ln 3e. And that will give you the full 3 marks. You're only going to get 2 marks if you get up to this stage here. So part B. The curve C1 meets the curve C2 at x equals alpha and x equals beta as shown as figure 3. Using a suitable interval, find a suitable function that should be stated. Show that to 3 decimal places, alpha equals 1.134. The iterative equation is used to find an approximation for B. Oh, okay, no, sorry, that's the second part of the equation. Okay, we just want this part here. I mean, question even. So, what we're going to do is we know that they intersect. So if they intersect, we're going to set them equal to each other. So we're going to have 5 e to the x minus 1 plus 3 equals 10 minus x squared. Okay, so if I move everything to the left-hand side, I'm going to get 5e x minus 1 plus x squared minus 7 equals f of x. So now we need to show that alpha equals 1.134. So if I substitute in f of 1.1335 and f of 1.1345, and then hopefully when we put these in, we're going to get a sign change. So I'm going to get 0.001 and minus 0.007. So, change of sign, and continuous. Therefore, alpha equals 1.134. Okay, nice and easy, 3 marks. Then part C. says using a suitable using a suitable interval and suitable function that should be stated, show that, the iterative equation x to the n plus 1 equals minus the square root of 7 minus 5e xn minus 1 is used to find an approximation to beta. Using the iterative formula with x1 equals minus 3, find the value of x2, find the value of beta, giving each answer to 6 decimal places. So first of all, what I'm going to do is I'm going to put into my calculator minus 3, and then press equals because that's my answer. So I know to find x2, I need to have minus 7 minus 5e, and I'm going to have minus 3 minus 1. But in my case, instead of writing minus 3, I'm going to write answer, so that as I keep going, I can just keep pressing equals, and then I'm not putting all of the decimal places into my calculator because it is going to take forever. Okay, so the first answer I get for x2 is minus 2 point, and it wants 6 decimal places. 6283876, which is going to round to 8. So now what I'm going to do is I'm going to press equals again, and I'm going to press it a few times until what you're going to notice is that it is going to come to a stop, and it has. So an approximation, and what I mean by stop, we're going to get the same number over and over again. Every time I press answer, I just keep getting the same number. So my beta is minus 2.620330292, which is just going to be 0 to 6 decimal places. So nice and easy, 9-mark question. Question 7. Express cos x plus 4 sin x in the form r cos x minus alpha, where r is greater than 0 and 0 is less than alpha, which is less than pi over 2. Give the exact value of r and give the value of alpha in radians to 3 decimal places. Okay, it's told us radians. Make sure your calculator is in radians, please. Mine is not. So, radians, done. Okay then. So, for 7a, we know r cos x minus alpha using the the addition formula. This is going to equal r cos x cos alpha plus r sin x sin alpha. So we can now compare. We have cos x plus 4 sin x. So what we're saying then is 1 cos x is r cos alpha, and we are saying that 4 sin x is 4 sin alpha, obviously sin x. So now what we have is r cos alpha equals 1, and we have r sin alpha equals 4. So we know there is a relationship between sine and cos. Silly cow is tan, so we know that sine alpha over cos alpha, we can keep the r's there because they're going to cancel anyway, equals 4 over 1. So tan of alpha equals 4. So alpha equals, so on our calculator, we're going to do shift tan of 4, and we're going to get 1.32581. It wants 3 decimal places, so alpha equals 1.326. Now, is 1.326 less than pi divided by 2? Because it says it needs to be in that, and it is, because pi over 2 is 1.57. Sometimes in these questions, you need to then maybe find the acute angle instead of the obtuse. So in this case, that's okay. And then to find r, we know r equals the square root of 1 squared plus 4 squared, which is root 17. So I can now rewrite this in the form root 17 cos x minus 1.326. Okay, part B. A scientist is studying the behaviour of seabirds in a colony. She models the height above sea level, h metres, of one of the birds in the colony by this equation, where t seconds is the time after it leaves the nest. Find, according to the model, B, the minimum height of the seabird above sea level, given your answer to the nearest centimetre. Okay, so we want to find the minimum height. Okay, it's only worth 2 marks, so we know there's not really a lot to do. If we look at this equation here, we can see we have cos and 4 sine. Again, have a look at your part A, and when in doubt, look up. Okay, does it have a similarity? It does. So instead of having x, we have half t. So here we're going to have a half t. So if I rewrite this equation now, our height equals 24 over 3 plus root 17 cos, and instead of x, it's a half t minus 1.326. So to find the minimum height, we have a fraction here. So we want the biggest denominator, essentially. We know that the cos graph has a maximum at 1 and a minimum at -1. So we're going to take the maximum of 1. So to find the minimum height, we're going to have our value divided by 3 plus and then root 17 times 1, which is root 17. That's going to give me to the nearest centimetre. Okay, so let's double check our units. It says h is in metres. Okay, so if we're doing this to the nearest centimetre, I get 3.3693. This is in metres. To the nearest centimetre is to 2 decimal places. So this is equal to 3.37 metres. Please be careful with your units. And then part C. The value of t to 2 decimal places when h equals 10. So that's nice and easy, because all we've got to do is substitute in 10 equals 24 over 3 plus root 17 cos a half t minus 1.326. If I multiply, I'm going to get 30 plus 10 root 17 cos half t minus 1.326 equals 24. I'm going to minus 30 and then divide by 10 root 17. So I'm going to get cos for half t minus 1.326 equals minus 0.6 over root 17. Now, shift cos minus 0.6 over root 17, which is going to give me 1.71. So a half t minus 1.326 equals 1.7168. If I add 1.326 and then multiply by 2, I'm going to get t equals 6.0856. Wants 2 decimal places, therefore t equals 6.09. So, again, nice and easy, especially because, you know, for part C and B, once you make that connection, the A is trying to help you substitute it in and use that formula. The curve C has equation y equals g of x, where g of x equals e to the power of 3x sec 2x between minus pi over 4 is less than x is less than pi over 4. A says find g of x. So we have a product. So we know we've got e to the 3x sec to the 2x. We have our v and u. So v equals e to the 3x. dv equals e to the 3x multiplied by the differential of the bracket, which is e to the 3x. U equals sec of 2x. And du we know is sec x tan x, but because we need to multiply it by the differential, so 2 sec x tan 2x. So to find the differential, we need to do v du plus u dv, which is going to be 2e 3x sec 2x tan 2x plus 3e 3x sec 2x. So nice and easy, 2 marks. B says, hence find the x-coordinate of the stationary point of C. So we know when we have a stationary point, the gradient equals 0. So I can see I've also got a common factor of sec 2x and e to the 3x. So that means I can factorise out e to the 3x sec 2x. Sorry, it doesn't equal, bracket, and then I'm going to have 2 tan of 2x plus 3. This needs to equal 0. I can multiply both sides by e to the 3x sec 2x. So then I have 2 tan 2x equals 0, plus 3 equals 0, so that equals minus 3. So tan of 2x equals minus 3 over 2. So then if I shift tan minus 3 over 2, I get tan of 2x equals minus 983, which has to be in the interval between minus a quarter x and minus pi over 4. And we know here we've got 2x, so I'm going to change my interval. If I continue up here, I'm going to have minus pi over 2 is less than 2x, which is less than pi over 2. So if I have my cast diagram, I now have 0, pi, 2 pi. This is pi over 2. And I've got minus 0.983. So now, what is pi over 2? So shift pi divided by 2 is 1.57. So we know it's roughly here. Now with tan, normally what we would do is we would reflect, we just go straight across, don't we? So we have it here. And we know that this angle is minus 0.983. And we can see the other one is out of the range, so it is just 2x, we know equals our minus 0.983, 827, blah, blah, blah. Divide that by 2. I'm going to get x equals minus 0.49139. So if we round it to three significant figures, x equals minus 0.491. Because it doesn't actually specify, so I think three significant figures is quite good. Then this was part I. We're now moving on to part II. Different curve has the equation x equals ln of sine y, where 0 is less than y, which is less than pi over 2. Show that dy by dx equals ex over f of x, where f of x is a function of e of x that should be found. So, we know that this is, we have x equals ln of sine y. So, if we differentiate x with respect to y, we know that ln differentiates to 1 over the bracket, so we're going to get 1 over sine y, and then we need to multiply by the differential of the bracket. The differential of sine y is, in fact, cos y. So we know that dx by dy equals cos y over sine y. Now, we always need to remember, how do we rearrange our part II? Our x equals. So we know that we've got cos y over sine y. So we know that dy by dx is 1 over that, which is sine y over cos y. Now we have a sine y in the original equation, so if we rearrange this, get x equals ln of sine y. To get rid of the ln, we're going to e both sides, so e to the x equals sine y. So I know I can substitute in sine y in our numerator. How do we find out what cos y equals? Well, we know that famous identity. Sine squared x plus cos squared x equals 1. So cos squared x equals 1 minus sine squared x square rooted. And then that's what cos equals. So remember, sine squared x can also be rewritten as 1 minus sine of x squared. And we know what... Sorry, I've used x's here. This is a bit confusing. Imagine these arrays. Okay, and in our case, we have sine y. So we then know that our numerator is going to be dy by dx. So sine y we know is e to the power of x over, and cos y can be rewritten as 1 minus sine y, which we know is e to the x squared. So if we simplify that, we're going to get e to the power of x over square root of 1 minus e to the power of 2x, because we know laws of indices, we can multiply the powers. Okay, so nice and easy 4 marks. And always remember with these questions, they give you what you need to substitute in the original equation, okay? So there we go. Question 9, and this is the last question of the paper. And 9a, given that x to the power of 4 minus x cubed minus 10x squared plus 3x minus 9 all over x squared minus x minus 12 is equivalent to, and then you can see here they've simplified it. And we do have a quotient. We've got to find the value of p and show that q equals 5. So straight away, long division. Now, I'm a big fan of I'm a Silly Billy. Helps everyone remember what's going on. So we know we're dividing by. I'm just going to make it a bit smaller. So x squared minus x minus 12. And we have x to the power of 4 minus x cubed minus 10x squared plus 3x minus 9. Now, this is my I'm a silly Billy. Okay, my teacher taught me this when I was much, much younger. So into x squared, how do we go, how many times does that go into x to the power of 4? And it is x squared. So now we multiply x squared times x squared is x to the power of 4. X squared times minus x is minus x cubed. X squared times minus 12, minus 12x squared. The m, subtract. So we're going to get 0. Minus x cubed minus minus is also 0. Minus 10x squared minus 12x is 2x squared. And then the last bit, bring down. So plus 3x minus 9. Then we go again. X squared goes into 2x squared how many times? And this is actually plus 2. And now we multiply 2 times x squared, 2x squared, 2 times minus x, minus 2x, 2 times minus 12, minus 24. Subtract. So 2x squared is going to cancel 2x squared. 3x minus minus is plus 5x. And minus 9 minus minus 24 is plus 15. Okay, and now we finish. So now what we know is, for part A, this is completely equivalent to x squared plus 2, and then we have a remainder of plus 5x plus 15 over x squared minus x minus 12. But you can clearly see that it's not in that form. So what I can see is I can see that I can factorise. 5x plus 15 can be factorised to 5 lots of x plus 3. Our denominator, x plus 3, x minus 4. We can cancel the x plus 3's. So therefore, x squared plus 2 plus 5 over x minus 4, therefore proved. Okay, so that was quite nice and easy. Part B. The curve C has the equation y equals g of x, okay, which we have just simplified up here. Find the equation of the tangent to C at the point where x equals 2. So we need to differentiate this. Give your answer to the form y equals mx plus c, where m and c are constants. So we need to differentiate to find the gradient function, substitute in x equals 2, so then we can find the gradient of the tangent, and then typical y equals mx plus c. So, part B. If y equals x squared plus 2 plus 5, x to the minus 4 to the minus 1, then dy by dx we're going to have is 2x, 2 differentiates to nothing, and then we're going to have minus 5x to the power, x minus 4 to the power of minus 2, because we bring the power down. Now what I'm going to do is substitute in 2. So minus 5 lots of 2 minus 4 to the power of minus 2. So this is going to end up with 4 minus 11 over 4. Okay, so this is our gradient. Now it's the tangent. We need to figure out what y is. So I need to substitute y equals 2 squared plus 2 plus 5 lots of 2 minus 4 to the power of minus 1. So our y is in fact 7 over 2. So I'm going to come here. So now we know we have our coordinate 2 and 7 over 2. We know our gradient is 11 over 4. Equation of a straight line, y equals mx plus c. So I'm going to get 7 over 2 equals 11 over 4 lots of 2 plus c. 11 over 4 times 2 is 11 over 2. 7 over 2 minus 11 over 2 c equals minus 2. So therefore, y equals 11 over 4x minus 2. So we found the equation of the tangent. So nice and easy, 5 marks really. Now for part B, C. So figure 4 shows a sketch of the curve C. The region R, shown shaded in figure 4, is bounded by C, the y-axis, the x-axis, and the line with the equation x equals 2. Find the exact area of R, given your answer in the form A plus B, ln 2, where A and B are constants to be found. Okay, so to find the area bounded by the curve, I need to integrate in between 2 and 0 of our equation y, which is x squared plus 2 plus 5 over x minus 4 with respect to x. So here we go. When I start integrating, I'm going to have between 2 and 0, x squared, increase the power by 1, 3, divide by the new power, increase the power by 1, 2x. I know when I integrate, x, this is to the power of minus 1. So if I increase the power, I get 0. So I know it's going to integrate into a ln. So I'm going to get plus 5 ln x minus 4. So now I'm going to substitute in 2, and then I'm going to substitute in 0. So remember, I'm taking the modulus of the ln x minus 4. So when I substitute in 2, I'm going to get 2 cubed, which is 8 over 3, plus 2 times 2, which is 4, plus 5 lots of ln, and then the modulus of 2 minus 4 is minus 2, which becomes 2 because we take positive, minus 0 cubed over 3 is 0, plus 2 lots of 0 is 0, 5 ln 0 minus 4. 0 minus 4 is minus 4, but we're going to take modulus, so I'm going to get 5 ln 4. Now, the question clearly states we want it in ln 2. Lucky for us, ln 4, we know that 4 can be rewritten as 2 squared. We know using log laws that this is the same as, remember the log law, log AB equals B log A. Okay, so that means that this is actually 2 lots of ln 2, and 5 lots of 2 lots of ln 2 is in fact 10 ln 2. So now I'm going to have 8 over 3 plus 4, which is 20 over 3. And then 5 ln 2 minus 10 ln 2 is minus 5 ln 2. And you can see here we have it in the exact form a plus b ln 2. Now during this question I've skipped a few steps, you know, like putting this 2 cubed over 3 and doing some of this in my head. Again, we should all be really confident with that. These are skills that everyone should know. It's more what we're doing here. So well done everyone. Please remember to subscribe. I hope this was okay for you. Have a wonderful day.